Hello guys, welcome to the channel. So let's see what's the problem of the day. The problem of the day is queue reversal. So it is a basic level problem, and the problem statement is that we have given a queue containing n elements. The task is to reverse the queue. Your task is to complete the function reverse that reverse the n elements of the queue. So here we are given a queue, and these are the elements in the queue. So we have to reverse these elements. Okay, so let's see what will be the time complexity and space complexity is required. So we are required with the big O of n time complexity and big O of n space complexity. So what we have to do, we have to reverse these elements of q into this form. So after reversing, we will get this 4 at the end of this and this 6 at the initial of that. Okay, so here we are given, so this is our q. Okay, what is this is our q. So we have to reverse these elements. So to get, we get 6 2 0 1 1 3 and 4. So after reversing, we should be getting this elements in the q. So how do we reverse it? So we all know what is q. Okay, the queue is the data structures which contains the element and follows the rule first in first out, which means that if the element is front in the queue, so first we have stored 4, so it is in the front of the queue, and then we have put 3 into the queue, it will be after 4, and then 1, it will be after 1. So if you are thinking that we can push 4 and refill it in the queue, so after doing this we will be only getting 4 3 1 1 0 2 6, but we have to reverse it. Okay, 6 0 6 2 0 1 1 3 4. So what we can do in this problem, that you might be thinking of, okay, what we have to do. So in the question you can see that we are allowed to use the space of big O of n. Okay, if we are allowed to use the space of big O of n, so choose the data structure wisely what we can use. Okay, so store these element in some data structure. So let's say I have taken this vector. Okay, because I can use the vector traversal from front to end and from end to front. Okay, the traversal in array is possible from front to end, that is from 0 to size of vector and from size to 0. So we are using vector or array to store the elements of the queue. What we will do, we will take the element, and what is the procedure, we can take the queue dot front. We will take the queue dot front and we will push into the array. Okay, and then we will pop it. We will take the front element, which is 3 now, we will fill it into array, and then we will pop it. Then we will take the front element, which is 1, and then we will pop it. Similarly, until the queue is empty, we will be performing the same function. Okay, so now we have filled the array with the elements of the queue. So these are the similar elements which were present in our queue, and now they are in our array. So we have to reverse the queue. So just traverse without doing anything, just traverse from backside to front, just reverse from backside to front, and put this element into the queue again. So take this element from the end of the array, which is array of size minus 1. If the 1 2 3 4 5 6, if the size of the array is 7, so let's say the size of the array is 7, so take the seventh element. Okay, we will traverse from end to front. Take the last element and push it into the queue, because once you push the element into the queue, it will be in the front of the queue. Okay, so now decrease the iterator to 2. Now we have 2 at the iterator. Now iterator is pointing at 0. We will take it and we will push it into 0, push it into our queue. Then we will again iterate. Iterator will be decreased, and similarly we will be performing the function, and we can see this is the required result in the queue. First, so what is the first step? First step is to empty the queue and put all the elements of the queue in the array. Okay, put all the elements of the queue into the array, and then again traverse the array and put all the elements of the array into our queue. So we get the reversed queue. Okay, so we get the reversed queue. So this is how we can reverse our queue. Okay, so now we will be doing coding, how it's done. Okay, so what we have to first do, first take the size of q, which is n is equals to q dot size. Okay, now what we have to do, while not q dot empty. Okay, while q not q dot empty, until the queue is not empty, we will be performing operation. What's the operation? The operation is that int x will be containing the front element of the queue. X will be containing the front element of the queue. If we have stored the front element, then we can pop it, q dot pop. Now what we have to do, okay, we have to initialize a vector int array. Okay, we have our vector int. Okay, so now what we have to do, we have to push the front element. Which is the front element? It is x. Now we have to push the front element to our array. So now when the queue will be empty, all the elements will be contained in our array. Now put all the elements of the array from the backside into our queue again. So for int I is equals to, what will I initialize? I will be initialize from n minus 1, because if the size of the queue is 7 and array is 0 based indexed, so we will be iterate till 0 and I will be minus minus. So now what we have to do, we have to push the element of array into our queue. The array of I will be pushed into queue again. Okay, and now after performing the function, what we have to do, we have to return the queue, which is now get reversed. So we'll compile and run and check if it is getting a expected answer. No. Array dot push, sorry, pushback. It's a pushback function. Oh, my bad. Okay, so these are the required elements, and the compile run it's showing through. Now we'll submit. So it's getting gets submitted correctly. So please, if you like the video and understood the concept, please make sure to subscribe the channel, like the video, and comment the part you didn't understand or you did understand. So now let's wrap up with that.